Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solutions of the questions that have appeared in the CSIR National Eligibility Test held on February 28, 2025. We now discuss the solution of a question from the real analysis. This question is placed in part B, which is a multiple choice question which carries 3 marks. The question ID is 704106. This question is suitable for all these examinations. The given question is: consider the power series sigma n is equal to 1 to infinity n power n square by n plus 1 power n square into x to the power of n with coefficients in real numbers in R. Which of the following statements is true? We are given 4 options. Option 1. The radius of convergence of the series is 1 by E. Option 2. The series converges at x is equal to 5. Option 3. The series converges at x is equal to 3. Option 4. The series converges for all x with mod x less than 1 by 2. So, this question is from the series of real numbers, and it is related to the radius of convergence or convergence of the series. Let's now discuss the solution of the problem in detail. We are given the power series sigma n is equal to 1 to infinity n power n square by n plus 1 to the power of n square into x power n. Let's call this as the sigma n is equal to 1 to infinity a n x to the power of n, where a n is the coefficient of x to the power of n is n power n square by n plus 1 to the power of n square, which belongs to R. The coefficients are coming from the real field. Agreed. Now, a n is equal to this one. This can be written as 1 by n plus 1 by n whole to the power of n square. Let us recall the Hadamard's formula for the radius of convergence capital R. It is given by 1 by R is equal to limit superior of mod a n to the power of 1 by n as n tends to infinity. This is the famous Hadamard's formula for the radius of convergence capital R. When the coefficient of x to the power of n is appearing in the powers of n, then this formula is suitable. Right. Now, limit n tends to infinity. Instead of limit superior, we calculate limit n tends to infinity of mod a n to the power of 1 by n. Limit n tends to infinity of mod of 1 by n plus 1 by n whole to the power of n square to the power of 1 by n. Then limit n tends to infinity of 1 by n plus 1 by n to the power of n. We have taken out the limit. We have taken out the modulus because these are all positive real numbers. Agreed. This is equal to limit n tends to infinity of 1 by 1 plus 1 by n to the power of n. And you know, limit n tends to infinity of 1 plus 1 by n to the power of n is the exponential e. That will be equal to 1 by e. Agreed. Therefore, 1 by r is equal to, write down the formula, limit superior n tends to infinity of mod a n to the power of 1 by n. This is equal to limit n tends to mod a n to the power of 1 by n. Why? Why? The reason is, whenever the limit exists, it is equal to the limit superior and limit inferior. Since the limit exists, therefore it is equal to limit superior. So that is why this equality is coming, and that is equal to 1 by e. 1 by r is 1 by e. We want r reverting. We get r is equal to e, which is approximately 2.718. Agreed. Now, the radius of convergence, capital R, of the series is e. Right. We recall a well-known result. The power series sigma n is equal to 1 to infinity a n x power n converges absolutely and uniformly for all x in mod x less than r. That means the mod x less than 1 means minus r to plus r, the open interval, for all x belonging to minus r to plus r. In that, for every it converges absolutely and uniformly for all x in the open interval minus r to plus r. Outside this open interval, it diverges, and diverges for all x when in mod x greater than r. That means outside the open interval minus r to plus r, it diverges. Agreed. With this, we move on to the next slide. Right, that's what we have, and this result also I have written down here. So now call on option 1. The radius of convergence of the series is 1 by e. Obviously, this is not true because the radius of convergence, capital R, is e. So the option 1 is not true since r is equal to e. Let's call option 2 and option 3. Option 2 says the series converges at x is equal to 5. And option 3 says the series converges at x is equal to 3. And it's very clear, the radius of convergence is r is e. That means in the open interval minus e to plus e, it converges. And for every x outside this open interval, it diverges. Now, x is equal to 5 does not belong to minus e to plus e, because x is equal to 5 and e is approximately 2.718. That means it is minus 2.71 to plus 2.71. In that, for every x, it converges. But x is equal to 5 comes outside that interval of convergence. Therefore, it diverges. So also 3 is bigger than 2.718. So therefore, it diverges. So options 2 and option 3 are not true since x is equal to 5 greater than exponential e and x is equal to 3 greater than exponential e. Now call on 4. So 1, 2, 3, they are all not true. Obviously, option 4 must be true. But let's see. Option 4, the series converges for all x in mod x less than half. So mod x less than half is less than e, because 1 by 2 is 0.5, this is 2.71. So therefore, the series converges for all x mod x less than 1 by 2. Since mod x is less than 1 by 2 is less than r is equal to e. Therefore, this is true. Option 4 is true. Thus, the answer to this question is option 4. Right. That is the detailed discussion of the solution of this problem from the section analysis. And it is definitely an easy question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We will definitely meet once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.